So on different airlines, you're allowed to carry on luggage. I don't know if you've ever been to the airport where they have this little thing and your thing has to fit inside of it in order for you to be allowed to take it on the airplane. And here are some restrictions for this airline. The whole length, width, and depth can't be more than 100. And a lot of carry-on luggages have a length 10 centimeters greater than their depth. So the first thing we're going to do is we're going to draw a rectangular suitcase here as a model. There's our suitcase. Has a nice little handle right here. There we go. And we're told that the depth, there's my depth, x, and the length is 10 centimeters greater. So I'm going to call this my length. And then this side is my width. And right now I'm going to put W, but we're going to want to write W in terms of the other ones. So for example, if I gave you numbers, if I said X was 20, does it make sense this side would be 30? Right? What would the other side be if you wanted to make it as big as possible? One side's 20, the other side's 30. The last side would have to be 50, right? Because they tell us we've got a maximum of 100 centimeters we're allowed to use. So if you had 20 and 30, the most the other one could be is 50. If I said this was 10, this would be 20. What would this side be? 7. So what I'm doing right now is I'm showing you that if I gave you numbers, you know how to do this. If I tell you I want W in terms of X, if this is X and this is X plus 10, how much is your width? Scary question. Does it make sense that, what did you do when I gave you numbers? You figured out what would add to make 100, right? You took 100 and you said, I've already used up X, and I've already used up X plus 10. Does that make sense? Like when it was 20 and 30, you were like, oh, there's 50 left, because it was really easy mental math to do 100 minus 20 minus 30 and get 50 left. But now, we have to do that same mental math, but with variables, and it's not hard, it's only hard to think about. But actually writing it down is not bad, and if I distribute the negative, can you see that this with 100 minus 10, you'll have 90 left, and minus 2x. And so now we have the dimensions in terms of x. And if we write out volume, length times width times height, doesn't matter the order. What's beautiful about this volume is it's already in factored form. In fact, you can draw a graph of this quite easily using the skills that we developed yesterday. So if I were to graph this, I would want to use my x-intercepts and y-intercepts and the end behavior. First of all, for the end behavior, I'm going to take out my purple pen here. I'm going to underline all my x's. Can you see that if you multiplied those together, you would get a minus 2x cubed graph, dot, dot, dot. If I just look at my x's and I multiplied that together, I would get a minus 2x cubed graph, which means its end behavior is going to act like a line with a negative slope. So now I know my end behavior. It's factored, so I could find my y-intercepts and my x-intercepts easily. Y-intercept is plugging 0 in for x. Oh, this is nice. 0 times anything is 0. And my x-intercept, if I split this up, this one's 0, this one's minus 10, and this one's 45. Obviously 0, 0 being a y-intercept is also an x-intercept. We have an x-intercept at minus 10, comma 0, and we have an x-intercept at 45, comma 0. With the end behavior and all of your intercepts, you can draw this graph. Also, do you notice that each of those intercepts has a multiplicity of 1? So your graph will go straight through each of those x-intercepts. So I'm going to draw a little graph of what's happening here. I'm not going to go and make ticking marks because I have to go all the way up to 45. Sometimes you just sort of go, oh, this is 45. And then draw everything else to scale as a result. If that's 45, would you agree this is about minus 10? Trying to be approximately to scale. And so I have this point, and this point. And I know my end behavior, so my graph has to go, start up here, straight through, straight through, straight through. And if we label our axes right now, this is x, which in our picture happened to be our depth. And this is y, or in our case, actually v, right? Because their y is the volume. And we drew the graph of the whole situation based on the equation. But another thing that happens in a real life problem is sometimes parts of it don't make sense. For example, this point right down here. Can you see that the y value, or the volume value, the v value, would be negative? Is it possible to have a suitcase with like a negative volume? It's like a little tiny black hole. This is where your socks go in and disappear forever. No. Some parts don't make sense. It also doesn't make sense to have dimensions that are negative. Negative 10 for your depth, that doesn't make sense. So I'm going to highlight this section in the middle, and I hope you realize that that's the only section that makes sense in our situation. Sometimes they'll ask you, what's the domain of this problem? The domain of this problem we would write as 0 to 45. I'd probably put round brackets on that. Like, if you included 0 and 45, your suitcase would be like a thin piece of paper that holds nothing, which would not be very useful to bring along on a trip. Probably you would argue anything really close to 0 is also not very useful. In fact, what we're looking for is this point. That point right there has the maximum volume. And for what we have right now, okay, what you're going to be expected to be able to do is draw the graph, okay? Finding this maximum without a calculator requires calculus. You're going to learn that next year. But for now, we're going to use technology to figure it out. Either a graphing calculator, or you can use Desmos at home. We're going to type this equation into our calculator. So I'm going to go to y equals, clear everything out, and I'm going to type in x, bracket, x plus 10, bracket, and 90 minus 2x. I type in the equation exactly like I see. Now, one of the reasons it's important to be able to graph this ourselves first is when I graph this right now, probably I'm on my standard window and this is what I see, which is not very helpful. Because the standard window only looks from minus 10 to 10. Can you see that we are really interested in this green box? That's what I want to see. I want to see that part hitting the maximum. So what do I know? I know that I need to at least go up to 45. Probably want to go a little bit higher than that I don't need to see anything in the negatives because it doesn't make sense, but I probably want to see a little bit of the negative because I like to see my y-axis. So I'm going to go back to my calculator.
Sorry for the interruption. With the grade 9 student council, please
And play with my window.
Grade 9 student council.
Because right now, my window says my x values go from -10 to 10. My y values go from -10 to 10. Well, I just need to see a little bit of the minus, so maybe I'll go -1. And I'm going to go up to 50. Because then I will for sure see past this 45. For the y, I don't need to see much of the negatives. So I'm going to go back to my window here. And for my y, maybe I'll just see -1. But I don't know how high it's going to go. Okay? Now, if you don't know how high it's going to go, you could get at least one example by doing a table of values. Do you see with our suitcase, I said at the beginning, a possibility for this suitcase could be 20, 30, and 50. 20 times 30 times 50 is going to be a big number, right? You can try it on our calculator to double check it. 20 times 30 times 50, that's 30,000. So my current window going up to 10 is not going to be even close to enough. So we can get an example by throwing in numbers to see what we need to go up to. I know I need to go up to at least 30,000. This is not a good example, but I'll try it. So I do 30,000 in 1. Now when I hit graph, oh, 30,001 wasn't enough, which I was hopeful it would not be. So based on this, if this is 30,000, looks like I should go up higher. I go back to my window, and maybe 40,000 would be enough. I hit graph again. Yes. And now I have this maximum. Okay. Other things that you can use to find your maximum and find your window. So the example that I did is I just looked at the situation and threw in one possibility to get an idea what the numbers were going to be like. I threw in 20, 30, and 50 just to see, right? Because if you use the guess and check method, most people start with 10, and they're like, it's not big enough, I'll try 20. How long is it going to take you to get to 40,000 in that method? A long time. So it's nice to try a value. Your graphing calculator also, above the graph button says table. So if you go to table, it actually tells you if x is 1, if x is 2. Oh, look at how it's getting bigger. And we can go all the way up to 45. But you maybe start noticing that after 28, 29, things start to go down again. So this tells me I need to go up to at least 36,192. So 40,000 made sense there as well. I've got my graph showing up. Your calculator has built in second trace button. No, I hit the wrong one. Second trace button gets you to all the things you can calculate on your graphs. And we want to find the maximum, so we'll go down to number 4 or type in the number 4. It says, which maximum do you want to find? Make sure you're to the left of it. Push enter. Move your cursor until you get to the right side of it. Push enter. Double check. Is the maximum between those two lines? Yes. Push enter again. And it finds our maximum happens to be 28.58 with a volume of 36,209.923. Wow, am I going to remember those numbers? 28.581. Comma. No, I'm not going to remember the numbers. 36,209.923. Units. What were our units? Centimeters. And so our volume would be centimeters cubed. Forget units and you get an E5 error. So the question is, let's read the question again. What are the dimensions to the nearest tenth of a centimeter? So when I go to my dimensions, we figured out x to be 28.6 centimeters. The other side, maybe I'll write by 38.6 centimeters by, and if we take 100 and minus those two, we get 32.8 centimeters. All three of those should add up to 100 centimeters. So it says, what are the dimensions? These questions you have to read to the nearest cubic centimeter. What is the maximum volume? So we'll write max volume is 36,209 centimeters cubed. That's, didn't round right. To the nearest cubic centimeter, 36,210 centimeters cubed. Did it ask anything else? Read it again. Okay. Graph the function. We did that. To the nearest cubic centimeter. Did that. What are the dimensions? What assumptions did we make? We assumed it was a rectangular prism. No curves to it, no problems with the inside. We simplified it a little bit. Luggage might have some inside bars right for the rollers, and that would affect the volume and stuff like that. Okay. Now, mathematically, whenever possible, it's nice to have an idea for what you just did. I think you all know how much a centimeter is. So can you visualize 28.6 centimeters? Like just a little bit less than a ruler. 38.6, 10 centimeters more, 32. It's a tiny little, kind of tiny. It's actually thicker than, it's pretty deep, 28.6 maybe. But can you visualize the volume? Does 36,210 centimeters cubed, can you visualize? Okay. Do you know how big 1 centimeter cubed is? Think about a centimeter by a centimeter by a centimeter, right? A little square like that, a little cube, that's a 1 centimeter cube.
Mr. JR, you have a question.
Yes? That was scary. Here is maybe something you know, but maybe something you don't know. 1 centimeter cubed, that's about this big. Okay? Sometimes in English we use the abbreviation CC for centimeter cubed. Have you ever heard of CC when getting vaccines or when getting medications? Like you need to take 10 cc's, which is 10 milliliters. 1 cubic centimeter, if you made a little tiny cup and filled it with water, it would hold exactly 1 milliliter. And you would still be thirsty. But 1,000 of those cubic centimeters would be 1,000 milliliters, which would be 1 liter. And so sometimes when you go to buy luggage, they actually tell you the size of the luggage in liters. Have you ever experienced that? Like if you go to Mountain Equipment Co-op and are like trying to you're planning on getting a backpack, they're like, this is an 80-liter backpack. And you're like, perfect, I want to put water in it. No. But it's a way of measuring how big something is. So now, if we're visualizing this, 36,210 centimeter cubed is like holding 36,210 milliliters, which is like holding 36 liters. And one of my favorite pastimes is eating ice cream, and you buy ice cream in those 4-liter, be like, you could go on a trip and take 9 ice cream pails in this carry-on luggage. Not recommended, it'll probably melt. You'll get in trouble with the airline, but you could. That is approximate size of what we have here. So just some things you probably don't think about. Okay, when you get an answer, think about the answer. Think about how big it is. What does it mean? Because sometimes you'll get answers where you go like, oh my goodness, my answer must be wrong. Yes.
Sometime in grade 10 recall, I don't remember what unit, but we had to calculate the area or like the length of fencing you needed, fence a single yard.
Yeah.
And then you had to convert into how much it would cost.
Yeah.
And confidently I handed the test in, and it was costing me $1 million
Ooh.
for a test. I wasn't thinking.
No. So, yeah, it is good to think if this seems reasonable. Okay, so with that, we can go to example 1. And example 1 is very similar to our jewelry box example that we did. Right. A piece of cardboard, 30 centimeters long by 25 centimeters wide. So here's my piece of cardboard, 30 centimeters on this side, 25 centimeters on this side, is used to make a box without a lid by cutting out squares out of the corner. This is exactly what everybody except Kevin did to get ready for today's class. Okay, Kevin wasn't alone. If you cut those squares out, you would fold along these lines here, and you would get a box without a lid, just like we did with our paper. What are the dimensions of this box? Well, it all depends on the size that you cut out of the square. So what we generally do is we say, let's cut out a square of size X, because I don't know how long that would be. If I do that, does it make sense that the height of the box will now be X? The long side was 30. But if I cut out X's, does it make sense that the long side, which was 30, you have to subtract 2 X's from that? 1 X on this side and 1 X on this side. And the shorter side that was 25, you have to take out an X and take out an X. And we could have done the same thing with our piece of paper if we wanted to figure out exactly the numbers that I started class with. Okay? Our volume, length times width times height, in no particular order, looks like this. Can you see, if I underline all the ones with an X, that this would make a positive 4x cubed graph? Because a minus 2x and a minus 2x and x would give me 4x cubed, which means I already know my end behavior. It's an odd function, so it's going to act like a line. It's positive, so it's going up from left to right. So if I just look at the x's, I got the formula from length times width times height. That's how we figure out volume. And we cut x out of the corner, so that becomes my height. Then each of these purple sides, now 2 x's are taken away. We can find our x-intercept because it's already factored, and I hope you can see that your y-intercept plug in 0 for x, your y-intercept is 0, 0 as well. So when we go to graph this one, I'm going to have to put 15 on there. 12.5 would probably be pretty close, maybe even closer. These are my x-intercepts. And since each of the x-intercepts has a multiplicity of 1, it's going to go straight through. And end behavior says I have to start down here, straight through, straight through, straight through, and so on. Now we're going to talk about the domain. What makes sense? Okay? And with the domain, if you include or don't include the endpoints, I'm fine with it. Okay? Sometimes the textbook will include them, sometimes they won't. Some people argue, well, you can't have 0 cut out because it doesn't make a box. Another person says, yes, it does make a box with no volume. Okay, so that's an argument to be had. First of all, if we label things here, this is our x, this is our volume, the x happens to be the height of the box, the volume happens to be the volume, surprise. So I hope you see that where the volume is negative, it doesn't make sense, right? Also doesn't make sense to have a negative x, a negative height. My question is, does this part and this part both make sense, or only one of them? I think this part makes sense. Can you cut anything out for x between 0 and 12.5? But this part here, even though the volume is positive, this part there doesn't make sense. Because that would be cutting out a square bigger than 15. Look at your original picture. If you cut out a square bigger than 15, how much paper do you have left? None. It's all gone. Because I can't cut out 15 and then another 15 from the 25 side. There's no paper left. So this section doesn't make sense. Only this section in the middle. And so we're going to want to graph this, and we're going to want to find this maximum. So if we reread the question, and these questions are notorious for asking you multiple things. Write a polynomial in terms of x. We did a. That's right here. Graph the function. What is its domain? Did we write the domain? No. 0 to 12.5. Again, I would accept square brackets or round brackets. So part B, we've done that. To the nearest cubic centimeter, what is the maximum volume? So you will need a graphing calculator or Desmos for this. So to do that, you're going to have to go to y equals. You're going to have to type it in. It was x, and then it was 25 minus 2x, and 30 minus 2x. Of course, when I graph, I have my window from before. It looks like I don't need to go that high, because this is the part that I want to see. I also don't need to go this far, because I want to see between 0 and 12.5. So maybe I'll go to my window and say -1 up to 15. I keep that 40,000 just to show you that's way too high. So again, if you want to get an idea of what would look like, you can go to your table of values and check out the numbers between 0 and 15. Looks like I get up to 1,500. So I can go back to my window and say, probably 2,000 would be enough. Oh, that's nice. Now I can find my maximum. I go in second, calculate, number 4, maximum. And it says start to the left. Now, I can, if you really like hitting calculator buttons, then you will enjoy this. You can look at the And you can keep hitting left until you get past it. If you don't like hitting calculator buttons over and over again, and I don't like it on the computer, because if I do it fast enough, I crash the whole program. But a shortcut is you can actually use numbers. So I know that I was going by ones here. 2 is definitely to the left. So if I just push in 2, it draws a line at 2. That's a lot quicker going to the left than hitting the left button like a woodpecker. Okay? 3, 4, 5, 6, 7. I think 8. I'm pretty safe at 8 for the right. Push 8. Yes. My maximum is in between those two lines. Push enter again. And it's at 4.526 and 1512. So, what questions do I need to answer? Nearest cubic maximum volume. So I should write max volume is, go back to my calculator, 1512 centimeters cubed. Was it to the nearest cubic centimeter? Yes. What size of square? Size of square. That was my x, because that's the height. My height is also the size of the square. Go back to my calculator. It is 4.526. What did it do? It doesn't say what the size of the square should be rounded to. So when things don't say, you should go 3 decimal places. So 4.527. Okay. And then the dimensions are to the nearest tenth. That's the next thing they wanted was dimensions. Okay. 4.5 centimeters by, you have to be careful here, because if you round early, we could make, like if you use the 4.5 to find your other sides, you're going to get a rounding error. So to get the other sides, and I'm going to show you something pretty cool on the calculator. After you calculate something, this is for AP, because you're going to use this a fair bit in AP Calculus next year. Like if I store that answer as x, notice it remembered it from the graph. So now I can do 25 minus 2x, which is 15.9. And if you use the 4.5, you would be off by a decimal point. And 30 minus 2x's is 20.9. Reread that last question. What are the dimensions? Yes, now that we have answered all of this. So there's a lot of things this question is asking us to do and get answers for in the end. Okay. Questions for practice? 3, 4, 5, 6, 9, and 10. Holy smokes. Circle those 6 questions. And then I'd like you to go to page 56, which is an empty page. And this was a 5-mark controversial exam question. Ooh, everybody likes controversy. And it was non-calculator. So we just did a max and min, right? They don't let graphing calculators on the final exam. So you're kind of like, sweet, I don't have to know this for the exam, the question we just did, because they won't be able to ask that. But they could ask this. And we're gonna work through how to solve this non-calculator one. That's very similar. They give you the box, they tell you, here's our box that has lengths x, x plus 2, and x plus 10. Write a function, here, I'm getting excited. I'll let you write down the question. I will wait. So then, the volume is length times width times height. Here's, and it has function notation, so I write it in function notation. X times x plus 2 times x plus 10. In this 5-mark question, writing that out was worth 1 mark. Then it tells us the volume is 96, so we can plug in 96 here. And this is where the controversy started. This is non-calculator. So do you think that the answer for x is going to be something like 3.251? No. Most students were pretty smart in realizing that it wasn't going to be that. That it was probably going to be a whole number. So then they were like, does 1 work? 11 times 3, 33 times 1? No. Does 2 work? 12 times 4 is 48 times 2, 96, perfect. X equals 2, done. It's the right answer, okay? But on the exam, people who did that method got 2 out of 5 marks, which, that's good base. Why the controversy? That seems extra hard, okay? They expected students, they said that this word here, the fact that it said all, requires an algebraic solution. Just guessing and checking says you found 1, but you have no way of proving that's the only one, which it is. 2 is the only answer. But you have no way of proving it unless you solve it algebraically. So this was the expectation on the exam. You need to solve for x algebraically. This is an x cubed equation. The only way you can solve an x cubed equation is if you factor and it's equal to 0, but it's equal to 96. So first of all, you'd have to multiply this out. So choose 2 of them, multiply those first. Then multiply the rest. X cubed be 10x squared plus 2x squared will be 12x squared. This will be plus 20x. Here we go. Or you can multiply these 2 first and then multiply by x. Either way, you're going to get x cubed plus 12x squared plus 20x. And then you can finally make this equal to 0. And some students at this side said let p of x equal all of this. And now you have to use synthetic division and long division and figure out what would work. Without a calculator, which was a little bit kind of, because can you see, nobody does this, but the possibilities in 96, there's lots. There's 1, 2, you can divide by 3, you can divide by 4, you can't divide by 5, you can divide by 6, not 7, 8, maybe. There's a lot of options. And if you decided to start with like 96, you'd have to, with your factor theorem, try 96 cubed. That's not fair with a calculator. This is why the first method that students used was actually helpful, finding out that 2 worked. Okay? So we already guessed and checked and found out that 2 works. That means that P of 2 is equal to 0. And we can use synthetic division, and this was the expectation on this question. 1, 12, 20, and minus 96, and plug in a 2, and do our synthetic division. Bring down the 1. Multiply, add. Multiply, add. Multiply, add, and get that remainder of 0. So you would now get 0 equals x minus 2, then x squared plus 14x plus 48. Which you'd have to check. Can you factor further? Yes, you can. X plus 6, x plus 8. So algebraically, the possible values of x that work are 2, negative 6, and negative 8. However, in real life thinking, you can't have a height of negative 6 centimeters. That makes no sense whatsoever. So the only answer is x equals 2, and the dimensions are 2 centimeters by 4 centimeters by 12 centimeters. And that's what the question was asking for. And this is what they expected for 5 marks. So a change that has happened based on the controversy. Because there's a lot of teachers mad. Their students got the right answer, and they were only allowed to give them 2 out of 5 marks. And they thought that was extra harsh. So you will see that they've added the word algebraically to questions like this to force you to have to solve it using synthetic division and factoring. I'm going to put one like that on your test, and I'm going to put the word algebraically. Just a warning already. I can go down.